Hello pre-calculus students, and welcome to a video on evaluating functions. As you can see in the objectives, our goal here, our objective is to apply some function notation in order to evaluate functions. So in example 1 here, we're looking at a function, this function right here, and we're going to evaluate it according to several different objectives here. So let's look at the very first one, a, and we're going to find f of 3. Okay, so for a, f of 3 means you're going to replace all the x's with 3. So that's going to be negative 3 times, where it says x squared, I'm going to make that 3 squared, plus 2x, I'm going to make that 2 times 3. Okay, and we just have to evaluate that, and in this case, evaluate means actually get a value. Okay, so what do we have? We have negative 3 times 9, which is negative 27, plus 6, which is negative 21. Okay, simple enough. The next one, we're going to find f of x plus f of 3, and this is really just about getting you comfortable with the notation. So we know f of x is what's given up here. This is f of x. So there's going to be variables in our final answer. So f of x plus f of 3. Well, luckily we've already worked through f of 3. So f of x is going to be negative 3x squared plus 2x, and it doesn't say to replace x with anything there, it just says to write it. Plus f of 3 would be plus negative 21. So the final answer would just be, changing plus and minus, plus and negative to really subtraction, so minus 21. And that's it. You can't go any farther. Okay, the next one, actually the next two I want you to look at very closely because they look really similar, but they're really very different. So for part C, we're asked to take our function and multiply it by 3. So we're multiplying the entire function by 3. The other one, it doesn't say to multiply it by 3. It says replace x with 3x. So that's what we're going to do in part D. Okay, so let's do C first. Let me just set them both up. So 3 times f of x means 3 times the entire function, which is negative 3x squared plus 2x. Okay, again, I'm going to do these side by side. So 3, or f of 3x. Now this one means to replace every x with 3x. So I'm going to write what I had before, which is the 3, negative 3. But instead of x squared, it's going to be 3x squared. And then plus 2, but instead of x, it's going to be 3x. Okay, so again, in part C, we multiplied the entire function by 3. And in part D, we replaced the x with 3x. Simplifying these, we get negative 9x squared plus 6x for 3f of x, and for the other one we get, this is 9x squared, so this is negative 27x squared plus 6x. Okay. Same thing with E and F. They look very similar at first glance, but we're going to do the same kind of thing. We're going to do them not side by side, but at the same time. So E and F, we have negative f of x is E, and f of negative x is f. So for E, we're going to take the function and we're going to multiply the whole function by a negative 1 or negate it. So we're going to take the whole right side of the function, and it's going to be the opposite of negative 3x squared plus 2x. That's what f of x is, so negative 3x squared plus 2x. For part F, we're going to replace the x's with negative x's. Now in the case where we square it, it's going to go away. That negative sign is going to go away, but where we don't square it, the negative sign is going to stay. So let's just be careful to put these in parentheses, make sure we get this right. So we're going to get negative 3 times negative x squared plus 2 times negative x. Okay, let's simplify both of these. The first one is just negating each of the two terms, so it's going to be positive 3x squared minus 2x. The second one is going to be squaring each negative, well, squaring the negative x here. When you square a negative, you get a positive. So the first term is negative 3 times positive x squared, which is actually negative 3x squared. And the second term is minus 2x because there's no squaring going on here. You just multiply 2 times negative x. And there they are. Okay, G is going to be a little bit longer because we're replacing x with something a little bit more complex than just what we've had before. So we have f of x plus 3 equals, we take our original function and we're going to replace each of the x's with an x plus 3. So we get negative 3 times x plus 3 squared plus 2 times x plus 3. Okay, now we have to be careful here because x plus 3 squared, you have to multiply that out, right? X plus 3 times x plus 3 gives you x squared, and then the inners are 3x and the outers are 3x, so that's plus 6x, and then the 3 times 3 is 9. So this, I'm going to just do one more intermediate step here. This is negative 3 times the trinomial that we just found, x squared plus 6x plus 9 plus 2x plus 6. That's distributing here. Okay, that's where the 2x plus 6 came from. We still have to distribute here, here, and here. So we still have, this is going to be negative 3x squared minus 18x minus 27 plus 2x plus 6, just carrying those last two terms down. And now, last step is we can still combine like terms here. These are like terms, and these are like terms. There's nothing to match up with the negative 3x squared, so we just carry that down. Combine negative 18x plus 2x, that's minus 16x. Combine negative 27 and 6, and that's minus 21. You can actually, you can't factor out the 3. I was looking at that wrong, so that's the final answer. Even if you did factor out the 3, I was going to say it would be optional, so you don't really have to factor it unless it specifically says leave it in factored form, which would be something we're going to focus on later. Okay, the last one is f of x plus h. So h is f of x plus h. So if in G we replaced all the x's with x plus 3, in H we're going to replace all the x's with x plus h. Okay, so we get negative 3 times x plus h squared plus 2 times x plus h. And now we just have to carefully simplify this one. All right, we're going to do the same thing. We have to do an x plus h times itself. And when we do that, we get x squared. We have an xh and another xh, so there's two of those. And then plus h squared. All right, so let's simplify this now. So we end up with, here from here, okay, it's equal to negative 3 times what we just found. So negative 3 times x squared plus 2xh plus h squared. And then plus 2x plus 2h, again, just distributing here. One more distributive property, and then we'll combine terms if there are any. So we have negative 3x squared here. We have minus 6xh there, minus 6xh, and we have minus 3h squared. And then we have our plus 2x plus 2h. Now let's look at this for a second and look for like terms, and I don't see any. So that means, as ugly as it may look, because you always want things to simplify to smaller, fewer terms, that's the answer. So what I'd like you to do is I'd like you to give the practice problem a try. So now we're looking at a different function, and we're going to do these in pairs. So I'm going to ask you to pause the video and see if you can get f of negative x and the opposite of f of x, and then we'll compare answers, then we'll do the next two. Okay, so first of all, here's the answers, but you probably noticed, I just realized that there's a little typo up here, so let's just kind of fix that. This is supposed to be, these are all supposed to be g, so this is g of negative x and negative g of x, and then we're going to find g of 3x, 3g of x, and g of x plus 1. So these are all about the given function here for the practice, not doing the same function that we already worked with. All right, so here again, here is g of negative x and the opposite of g of x. There's not much really surprising for g of negative x. That usually won't cause too much trouble. But just a reminder, when you have the opposite of g of x, the opposite here, sometimes students will want to place a negative in the numerator and the denominator. And let me just remind you that something like, here note, that the opposite of 1/2, you could say the opposite of 1 over positive 2, but you can't say, right, if you have the opposite of 1/2, you don't put a negative sign in both numerator and denominator, or you're actually going to make it a positive. So you would only put the negative sign in numerator or denominator, and usually we do the numerator unless we already have a negative sign in the denominator, then that would be the one to usually change. Hopefully that makes sense. Okay, we're going to try now to do the next ones. So again, I'm going to have you try g of 3x and 3g of x, and I pause the video and then we'll talk about those in a minute. Okay, and there they are. For g of 3x, just replace x with 3x, and we can't really simplify this anymore. For the second one, notice that the 3, this is in the numerator, okay, so we can cancel it with this 3 in the denominator, and that just simplifies to 4 minus 5x over x squared. Okay, why don't you guys try the last one on this practice? Why don't you try g of x plus 1. Again, pause the video. Okay, now there's the final answer. Just a little side note is that this answer and this answer, they're both okay, unless it specifies whether your answer should be in factored form or not. I've been multiplying them out for my examples. So up here, there was like this one, for example. We could have factored out the 3. It looks like there's a 3 in that one, and there's a 3 in this one that we could have factored out, and that's about it. But yeah, these two could have been put in the form 3 times negative 3x squared plus, oh, actually 3x could come out. I take it back. So we could have actually written this as 3x times negative 3x plus 2. That would be okay. And we could have written this one out as taking a 3x out also, and that would be times negative 9x plus 2. So either way, if I don't specify, but just know that on a multiple choice or something, or if I do say in factored form, this is factored form, and then this is polynomial form. So expect, I'm not sure what to expect in the back of the book, but just be flexible and know that they are equivalent. Okay, I hope you found this video helpful.